People in the meeting. Join అయిపోయింది.
Hi everyone.
Hello, ma'am.
I am taking today's class just to clear few things, few questions regarding exam. That's all. You guys had few questions regarding exam. When is the exam date, by the way?
28 and 29, ma'am.
This month, 20th and 29th.
Yes. Last week.
October. Okay. Okay. After the setup. Okay. I asked few questions to sir, and sir told that usually, in exams, it will be having the exam will be having similar to the gate exam how we do, and then they'll not be allowing any calculators, scientific calculators or anything. They'll be having a normal calculator on the screen, which you guys will be able to solve the question paper using that. And then data sheet will be given to you guys. You'll not be writing any equations. In the data sheet, relevant equations which are required to solve the problems will be given. and then you need not to carry any written equations in that. And then it will be the exam will be very similar to the assignments that are given, MCQs and numerical type. Yes, Suresh.
Yeah. Good evening, madam. Yeah, I joined.
Hi, Suresh. Good evening. Actually, the reason why I was not taking the class because it feels like I am a student for this lab and then for this class, and then me teaching is like a little bit overwhelming for me. Metallurgy I can teach, but mechanical it's a little bit difficult for me to understand and then teach. Like I can only study right now, but not teach and all. That's why I stopped taking the class. But then sir asked to convey these points, and then Kannan was writing mails constantly. That's why I thought,
Previous weeks we have taken the class or no?
no, Suresh, I have not taken the
Okay, actually
class.
no. I was joining little. I was trying to join little late. Actually, I was coming back from office and not able
Texted,
to join. That's what.
I mailed NPTEL directly. Even I told to sir that sir, I'm having difficulty to take the class because the doubts. It's very difficult to. First, you should be understanding completely, and then if you take the class, it'll be better. But
Yes.
it was a little bit difficult for me to first study and then understand and then clear the doubts. So I
Mm.
thought this time I'll complete the classes and probably not mechanical metallurgy I'll take next time in fracture mechanics. That's
Madam,
what
at
I
least this
thought.
assignment questions also. Are you finding it difficult?
And like the chances are very high that I'm making mistakes,
Oh.
Suresh. Like yeah, this one, and then I realized when who is this? Like Kiran or someone? Huh? Kiran sent me the uh. It was very difficult for me to understand actually.
Hmm.
So then I understood that I'm doing a lot of mistakes even during the teaching also. That's why I'll probably take couple of more classes based on assignment only. Two assignments we'll try to complete. The one which are left, like that I'll do. I don't know, like I'm still haven't figured it out because even I have a lot of work going on. So
Hmm.
I'll let you guys know directly in the mail only. Uh, I talked to NPTEL, but then then I realized it is at least required to have a platform where if you guys have doubt, you can at least clarify among yourself. So I thought, fine, I'll take the class. And then I realized in assignment 4 also I was making a mistake. I've made so many mistakes in this also. So let me complete this exam part first. So where was I? You guys will be getting equations with the data sheet, and in that data sheet you will be having all the equation. You will not be allowed to carry any written equations, and the questions will be very similar to the assignments that you guys are solving, and then it will be MCQs and then numerical type. And so if you guys solve all the assignments questions that is given, and I have other previous assignments also, I can share with you guys if you want those assignments. So if you solve those questions, approximately 50 to 60% you will be able to score very easily in that. And then so I asked her to take one class to have a to clear the doubts. And sir was like, he will see whenever it's feasible. He was supposed to take one class at least. He said he will take, and I don't know when he will be taking. Did sir inform to you guys anything regarding that?
No.
No.
No,
I think so, but he was giving the answers for few questions in the discussion form, right?
ma'am, there is a clarification here. So who is responding to our mails? I thought it's you.
It is me and then other TAs are there, but then they are from mechanical. I am the one who is responding, obviously, to your mails and for all the mails, but NPTEL also will respond to your mails.
That is admin, but technical responses comes from yourself or your colleagues, right? Not from sir.
Yes. No, 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 not from sir.
Okay, so we don't have any mails from sir. Or, we never received any communications from on mails from sir.
No, no. I mean, informed sir personally regarding the taking classes, one class extra for you guys, so that you can clear the doubts that you guys have. Sir said he will see the feasibility and then he'll take one class. Usually, they have to take one interaction session. Actually, it will be two interaction session. First, 6 classes within first 6 classes, one interaction session should be there, and next 6 classes, another interaction session should be there. That's how it is usually done. So I reminded sir regarding that, and sir was like he'll see if it is feasible, he'll take. So.
Madam, other subjects, no, other subjects, they in none of the subjects. I have attended some other courses also.
Huh?
None of the courses that main the
Live
professor is
interaction.
taking this. He was not taking all these
No,
TS were only.
I was TA for another. Even they had the doubt similarly.
Uh-huh.
So for other classes, I asked them to attend the one live interaction directly because it was little bit difficult. I mean, that was metallurgy. It was manageable for me. But I feel like this one, sir, should take one class at least for you guys. So even that time also, that was scanning electron ion microscope, microscope that was regarding SEM. The course was regarding that. So for that, I requested, so they took 2 classes. In first 6 lectures he took in around third or fourth lecture, and next 6 lectures he took around at the once the lectures were all done, he took it at the near the exam time.
In fact, other subjects, no, two TS were taking classes together.
Yes, I
Sometimes
don't
they
think
were
so
independently. They
anyone
were
is.
taking twice in a week. It's a two classes in a week, and
I don't think so
sometimes
anyone has enrolling for this class also. I don't think so anyone is enrolling for this one.
no other
Uh,
subjects. Other subjects. I have
Yeah,
the
other
TS.
subjects like TAs should apply for this, and this
Oh,
is the first time ever I have applied, and I applied by miss.
maybe for this subject, maybe TS were not getting ready. Maybe for other subjects,
It
I think
is a little bit difficult, Suresh. I have to
yes.
first go through, and then I have to keep on track of all the equations, and it's like I don't have that strong background in mechanical. So, like, I thought fracture mechanics in metallurgy. It is very interesting, fracture mechanics in metallurgy, actually. I wanted to learn fracture mechanics in metallurgy. That's why I took this. Um, and anyway, apart from that, and one of the equation, in this, I got one clarification. One had doubt regarding this one. Uh,
To this one, sorry, ma'am. On the exam part itself.
exam part I completed, right? I'll ask
No, but
sir to take
there
one.
are some,
Yes, good.
there are some clarifications in what you told.
Uh-huh.
First thing is you are told that they'll be providing some data sheets with the equations, right?
Yes, with the equations related to the questions.
Mr.
Can you
Khan,
please?
can
Yes,
I
Suresh,
intervene, madam?
Yes,
yeah, please.
please, please.
Yeah. No, frankly speaking, I have attended last year also. Okay, of course, I could not get through. I could not.
Even me too. Suresh. That's what I'm coming to tell. Because
Yeah,
there
actually,
was no data provided last year.
in previous semester, the subject was not there. Previous to
So,
that, no, I have attended this. The questions were like this. Actually, similar to this assignment itself. Whatever data is required, and then some of the critical the formula and all, they were giving in the question itself as a part of question. There was no separate booklet or something. Like in the week 10, some of the questions, actually the equation was also given, if you can see. Similar to that, they have given some of the equations also. Of course, that time I did not, just like that I have attended. This time I took it as seriously. That's what.
So continuation to Suresh Babu, we didn't get any data sheets, ma'am, questions, but there were, as I told, there were equations for some of the questions, not for all. And it
But
was like please let me complete. It was like
yes,
memorizing the equations every time and writing it. So it is difficult, but I think if you can reconfirm that the data sheet equation will be provided, it will be good. If not, I will have to memorize the equations in all weeks. Is what my plan is.
so
I think it is
what
not
sir has
necessary.
replied is similarly to this one. A data sheet with relevant equations will be provided. They need not carry written equations.
maybe this is the understanding what sir has. See, now there is different parties handling this process. There is NPTEL admin. Maybe somewhere there is chances that some things are miscommunicated, not communicated properly, and that's why the data sheets we didn't receive last year. So same thing
Okay.
should not happen. So
Okay,
if
so I have to confirm this one whether the data sheet means will there be separate data sheet apart from the questions, or will it be along with the questions like Suresh was telling? I have to
It
ask
will
this
be along with the
question,
question
right?
only. Question only. Nothing separate. In fact,
Okay.
what happened? Some for 4-5 questions together, the formulas will be given in like for 4-5 questions at a time. In fact, it will be find it difficult which formula for which question. That I think unless you go through in the present course itself, it is difficult for you which formula belongs to which question. Okay, 4-5 questions together, they will be giving a formula. It was like that. Am I clear, Mr. Kanam?
I'll ask it anyway. Will the data sheet will be given separately or it will be along with the question? This is the question that I have to ask to sir, right?
yes, ma'am, that will be better.
Huh.
Yes.
Okay, I understand that you have there might be any miscommunication or something in NPTEL and they might not give the data sheet. I got your point. Fine, I'll ask regarding this one. This I can ask. Anything else you guys have questions regarding this one? And very similar to assignment
Yeah.
MCQ plus numerical type. If they meticulously do the assignment questions, I believe they can score minimum of 50-60%. I asked sir and discussed few questions, and then they wanted to know the question pattern, how the question pattern will be there. So for that, sir only replied on the questions that I asked. Everything is like this. They had few doubts last week, sir. I texted him around 11 September. By harmonic equation derivation, they wanted to learn and they wanted to have a live session with you, sir, and discuss few questions and question paper pattern, and wanted to know if scientific calculator is allowed in the exam, and can they write equation and get for the exam. Aries stress function, further explanation is needed. Further clarification on plane stress and plane strain. Like we were having a little bit doubt, I remember. And they wanted the assignment with a little bit earlier, as it is confusing them a lot. These are the questions that I asked, and I got only few replies among that.
Madam, for all the questions, for all the assignments, if you can provide us the solution part, that will
Huh.
be just providing this assignment questions may not be sufficient.
Can we do something like next time onwards? Like I'll take the class on Tuesday, but then I don't think so I'll be able to solve everything completely. Can we all discuss and then do the assignment then?
Okay.
Yes, ma'am. That's
Yes.
good, ma'am. Actually,
Huh? We
yeah,
will
this
try
is
to
good, ma'am.
solve it. Yeah, I mean, because I don't know where I'll go wrong. The chances are very high that I'll use wrong equation. I realized later and I felt like it's better not to teach wrong than so that's why I thought I'll first take the class and then I'll complete it. So we can
Madam,
do that, like
even
we
for the
can
previous class, even for the previous assignment, do you have this doubt?
yes, from fourth assignment, like I have the doubt from fourth
But for
assignment.
already answers must be available, no? Then I think answers
No,
are
I have
available.
used here in this assignment, for instance, we have to use the problem equation which I have used is not correct. I have used strain energy equation, but we
Hmm.
have to use strain energy release rate instead. Oh, no, we have to use strain energy equation, but I have used strain energy release rate, and for this equation we have to first find out the one second. So first we have to use strain energy release rate equation, and since the moment is not given, we have to find out moment is equal to P into A, and then we have to integrate it in this equation.
Okay.
So that's how I realized that I'm making a lot of mistakes actually.
Actually, no, madam, whatever if I go through the class notes, whatever
Hmm.
the no,
Hmm.
most of the things are coming from that. Very
Most of the things are coming from where?
Yes, 70 to 80% if I just make
Acha, we have to do the assignment. So we can do that. Then we will just solve the assignment. We'll try to solve it, and we have previous assignment also. We'll discuss and do it. Then that's all I can do actually, because I'm using the equations wrong way. That we shouldn't find first stress. First we have to find out the moment, and then we have to integrate it some, and then we have to find out the strain energy release rate using that equation.
Actually, this fourth assignment is very actually even for every week. No, we can do. I could able to do it immediately, but I am forgetting the previous ones.
Yeah, exactly. That is a problem because like when I was doing the fourth assignment week, that time I was remembering the equations and all. And when I come to sixth week and I'm forgetting what is happening in fourth week, I'm not even able to solve or try to understand what is wrong in that week also. So that's where I realized. So that's how we have to do
Please
first anyway. Momentum we have to use. We have to integrate it.
Present assignment, I think you are asked not to discuss, is it? Otherwise, maybe that may be easy little. Even the
No, you guys can discuss, man. If you guys want, you can discuss. It's fine.
okay. The present assignment we can discuss maybe to some extent.
I have not prepared though. Like I just wanted to tell you guys regarding this exam, and then yeah, one more thing is here R is in radius. So this was the doubts that you guys had. So R is in radius is in millimeter. We have to convert it to meters and then do the assignment. So keep an eye on the units that when you guys do. So R should be in meters, by the way.
Is it really fourth assignment?
This one, I think so it is fourth or fifth.
No, it's not fourth.
No, I'm just discussing the problem doubts you guys had.
Sorry to interrupt. Please allow me to tell some. So before going to these assignments and problems, so please let us have this session every week. Only we have 4 weeks, so please support us.
See, that's what I was
Okay.
telling. Like, I'm really bad at solving because I'm having difficulty keeping track of the equations every week. First, I have to go through the complete week, and then I have to probably teach it. That's what I was telling. We'll solve together, because
Yeah, that's good.
according to sir,
Yeah.
if we solve the assignments, about 50 to 60% of the marks we will be able to score it some. So we will. I'll take the class. I'll start, and if I'm making any mistakes, I want you guys to please say and have discussion properly. Then we'll just solve in the class only. Because previously I have made
Okay.
mistakes and no one pointed it out. That's why.
Everybody is learning, ma'am. So
You guys should be able to do this one at least. Come on, I made a mistake here and you guys kept quiet.
okay, ma'am. We'll see, ma'am. So we'll do it together, ma'am.
Yes,
But
that's
please,
what I wanted. Like if we that we can discuss, it's fine. Present assignment also we'll discuss. It's okay. If you guys have any doubts, you can discuss among yourself then.
fine, ma'am. Thank you. And
I can
somebody has raised
stop
hand.
sharing. You guys can start sharing the. Someone has raised hand. ME23E00. For this class, you guys discuss, like if you guys have anything to discuss, you can do the discussion.
Yes, madam. I am ready to discuss the present assignment.
You can share the presentation, Suresh.
Presentation? No, only the no.
Yeah, screen also you can. I have which class equation you wanted, by the way? Which class? I have week 6 prepared with me though.
No, I just week 10 is in progress, no?
Okay, fine. You can share week 10. I have not seen that only. I was busy. So you guys got regarding the question exam, right? You guys have idea now, right?
Yes. Yes.
That's all I wanted to discuss with you guys. So next week will be week 11, right?
Yes.
Week
11 is already uploaded. By next Wednesday we have to upload.
Okay, fine. Tuesday we will have on week 11. I'll also prepare. I'll prepare the slides and get, and then I'll prepare others also. And do you guys want to have class on Saturday and Sunday?
Yes, no issue.
Kanan,
Yes, ma'am. Because we
you
have
have
only 4 weeks. Let us complete all the weeks
again,
session.
Kanan. Like we will be just coming together and discussing. That's it. We'll try to solve and discuss. That's all, Kanan.
That's okay, ma'am. That's okay, ma'am. If
Okay.
none of us knows, then at least you may talk to your circle and let us know.
Fine, then I'll tell to sir that we are just having a discussion forum, sir. We are discussing the present assignment and we are trying to solve the assignment.
Yes,
That's
please.
all then.
Yes,
Fine.
please.
Then.
Yes, please.
Yes.
My screen could be seen.
Yes, Suresh.
Yes. Yeah, madam. Just no. Question by question. If you are, if you say yes, just I will proceed.
Next week we'll be sorry, not next week. Probably Saturday we will complete week 11. We will have the discussion on week 11. And then Tuesday again we will have either Saturday or Monday. I'll send you guys personally. Suresh, can you first give me your can you guys send me your email IDs here in the chat box? Whoever are here.
Sure, madam. Actually, no. I wanted to. In fact, no. Past few weeks, I was trying to attend this class. Actually, in fact, I was joining late. I'm not able to join. I thought you were not allowing.
And no, you
I
guys
don't
said
have a
just
mail
send me.
ID even how to communicate. That's why I could not communicate. So,
You
madam,
guys
this
please send me the your email IDs in the chat box, and then I'll send you the timings for week 12. Well, week 11. Week 11 we will try to solve next week.
Ma'am, actually, this is okay for us because we are few in number and now we are only 3.
Yes.
There are other like Nirud told that he'll not be able to join today separately on my mail. I can inform him and Arjun who are in contact with me.
Okay.
But there could be other people who may be interested, but they will not be able to join today's session. What can be done for those people?
Okay, fine. Then I'll ask directly NPTEL only to send the mail to everyone then.
Yeah, please. That will be good, ma'am.
Okay, that's fine. I have your email ID anyway. So worst case scenario, it will be on Tuesday only. We'll be discussing on 11 week 11 assignment. Okay. Yes, Suresh, you can continue.
yeah, my mail ID just I have made. First question. Which of the following specimens is useful for the fracture toughness testing of the shafts? I believe this is yes. For shafts, it is disc-shaped compact tension specimen. Kannan, do you agree? Mr. Kannan?
Yes, Suresh. Yeah. Yes.
Is it a 3-point bend test? 3-point bend specimen?
Madam, 3-point bend specimen. Madam, just I will my process I will tell you. Whatever sir's lecture is there. Just I'll completely note down. Yeah, it is clearly it was told in that lecture.
Okay.
It is used
Suresh will explain that one now because it's not possible, right? If it is a 3-point bend specimen, how we can take a shaft with a minimal diameter, so it will not fit in. So it makes sense when sir tell that we use disc shape specimen for shafts or rods.
Yes. Correct. This is correct, no? Disc shape, we will go with this.
Yeah, it's what I also marked up.
Madam, it is confirmed. This is only the answer.
Okay.
And we can add that C specimen is for pipes.
Yes.
Because its shape itself will represent a pipe.
Correct. Correct.
It is notable. And for compact tension, it is what Sir told is for plate type of things. Thank you.
Which one?
Could
For
you
compact,
guys?
it is plate for plate, used for plate. Right?
That is for compact specimen, huh?
Yeah, compact tension, CT specimen.
Yes. Okay. Correct. For 3-point bend specimen, any specific application you told?
Especially when you want to find out the fracture KIC value, fracture toughness. That's when standard method for doing that. We do it even now also for when you take it single crystal. And you want to find out how the fracture toughness is there. So first we do EBST of the crystal orientation. We'll find out, and then with related to that we apply a force, and then we see up to when it starts cracking, and then we find out the fracture toughness using the formula. So for that we use 3-point bend test for finding out the KIC values.
Ma'am, for which type of which form of products you take 3-point bend specimen, ma'am?
The
Plate.
sample size is very small, and then the thickness and all we follow the ASTM standards. And the product recently I did magnesium. We have already done. We have a fracture toughness value for pure magnesium, but we don't have fracture toughness values with magnesium rare earth elements. So I was doing the experiment based on that recently. And we captured even the how the cracks are propagating and from where it is propagating. All those things we captured actually recently. That using 3-point bend test. 3-point bend specimen.
Okay.
Yes,
Come on,
you guys can continue. Yes. Next question.
This A denotes the plane strain fracture toughness, and B denotes the plane stress. Which value will be more? That is the question here.
By the way, did we get exact meaning of plane strain and plane stress? Like that day we had a little bit confusion. You guys understand? You have Kanan and Suresh. You guys have fair idea, right? Properly now.
Yes, plane stress. Plane stress means it is only specimen is very thin.
So
Okay,
plane stress means sample will be specimen will be thin sample, right?
yes.
Plane
In
strain is
plane,
thick sample.
plane strain is thick specimen, thick sample.
Yes.
But in this, no, exactly I don't know actually which value will be more. Denotes the plane which is more. That's why I thought it is insufficient data, because for the same specimen we cannot check the both.
No, fracture toughness will be higher in plane stress condition, no?
Is it?
Yes, ma'am.
Yes, ma'am.
In plane stress, fracture toughness is higher than in plane strain condition.
It will be usually will be higher and then it keeps reducing, Suresh.
Oh,
Yes.
madam, you mean to say plane stress condition? It is more. Is it that?
Plane stress, it is more, yes. Thin samples have higher fracture toughness compared to thick samples.
Can I add something, ma'am, here for better
Yes,
clarity
Kanan,
to?
yes, please. This is a discussion, so yes, please.
Suresh, if you go to week 9, okay, the question number 12.
Question number.
Sir
Shall I
has
open?
given. Yeah, please. Why not?
Shall I open that?
Yeah, please. Yes, it will be more.
Week 9.
Yeah.
I think you could see my this thing, no?
Yeah, I can see. Yes, week 9.
Question number 9.
We'll number 12.
Number 12. Yes.
Okay, this is this chart.
Yes.
So Sir has told that this becomes the KAC becomes a material property whenever the plane strain condition. Plane strain condition is attained here. In the first figure, it is 50 because it's constant after that one, after the thickness.
Yes.
So on the right of 50 mm for figure, it will be plane stress condition. On the left of 50 mm, it will be plane stress, and right of 50 mm, it will be straight graph, straight line. It will be plane strain. Is what I understand.
Yes. Exactly. Yeah, correct. I understand now. Up to some certain thickness, this K1C is more. Toughness is more. Fracture toughness.
So
After
that is
some,
plane stress.
yeah, that is plain stress.
Yeah. So it's more always than plane strain. So this
Yes,
is how I
exactly.
correlate.
Thank you. Good. Shall I go
Yes,
back?
Suresh. Next question.
My understanding is right now.
Tanan, you were telling something?
Yeah, my understanding is correct. No, whatever I conveyed is
Yes,
right. No,
it is correct. I mean, yeah, up to this much I can say, but when it comes to equation, I'm lost. I'm sorry.
that's okay.
Okay.
I'm lost in each and every question, ma'am. So no worries,
I'm
ma'am.
changing my
No,
answer.
Tanan, I don't think so. Yes, Suresh,
Okay,
next
ma'am.
question.
Third is residual strength diagram for a thin cracked panel is plotted
No,
between.
it is not seen, Suresh.
Huh?
Yeah, you have changed
Yes, I
to
have
week.
changed question number 3.
You guys are able to see Kanan and Ray.
No, ma'am. It's only half
Yeah,
I can.
Suresh, connection issue is there.
Okay. Just I will stop sharing and once again.
Ma'am, to be honest, it takes almost 2 hours to complete the test, ma'am, for me. This week 10 and all, week 9 and all, it took 2 hours for completing the test.
2 hours, that's it.
two
Kanan, believe me or not, when I was preparing for the class, I was spending 8 hours, more than 8 hours for preparation.
That's what we need to do, ma'am. Preparing for a class is different. Taking a test, that is open book test, is different now. So
Yeah, that is also true, correct.
that's why we need you. Thank you.
And
Can-
you wrote right. Yeah, yes, Suresh.
Is it easy?
We
Can
can
you
do.
see
Yes,
my
Suresh, we
screen?
can see.
Yes. This is question number 3. That's residual strength diagram for thin cracked panel. It is between stress and crack length. This plot is plotted between stress and crack length. I feel this is the correct answer. I think this was Mr. Kannan. This is his second lecture.
I went through it, but it was very quick. So but I don't think it's stress and crack length. It's energy release rate
No, actually,
versus
residual
else, right?
strength diagram. Just I am strictly going with respect to lecture notes. That's all. Okay. The residual strength diagram is clearly given that the strength in megapascals and crack length in mm or meters. That is given clearly. The plots were given in that lecture. Stress and crack length.
I did not.
It is there in lecture number 2 in the this week's week number 10. Anything you want to discuss? I cannot explain more than this. Such only it is there.
From next time onwards, I will get the answers, guys. If I'm wrong anyway, then we can discuss
I also
more.
did not come prepared for this actually. Otherwise, I may be little more prepared.
Yes, it is fine, Suresh. At least we'll go through the questions, and if you guys, or else Suresh, you can do one thing, whichever you are having doubt, we can discuss on that.
Yes,
Or
madam.
else hold on, like if any metallurgy related comes, then I can give my viewpoint also.
Okay. Mr. Kannan, this fourth question you are clear, is it?
Fourth question, no, I didn't answer because I still have one week lesson to complete, so I did not take that.
Acha, are you not submitting these assignments regularly?
Only tomorrow. My plan is only to submission tomorrow.
Okay. Okay. This is also just I could answer. It is actually it is very straightforward answer. And fifth also there is it's very clear actually. I just tried if anything this is also just I could get the answer from the directly from the notes.
You can hold on for 1 minute, Suresh. 1 minute. Identify curve statement regarding plane stress. It's okay. I'll go through the lectures again and then I'll come back to you guys. You
Actually,
can.
from the lecture, no, a stable fracture precedes the catastrophic failure. These things also I took from the notes.
Hello.
Excuse me,
yeah.
ma'am.
Yes.
In the question, there is no need of chevron notch because it is used for plane strain condition.
Suresh, can you back?
Correct. Yeah, chevron notch is not required. Yes,
And also in fifth question, the third option will also be correct. He mentioned in the lectures.
No part of the crack front. The fifth question, no part of the crack front shall be closer to the hand. Machine start not. Is it?
Yeah, he mentioned in one of the first lecture, I think.
No, I just not
You
that
can
notes.
go through once and
Suresh, can you show me the question? I'll try to see the question, please. 1 second.
This is the question number 5.
It's okay. I'm seeing in my laptop.
Yeah. Actually, just what. That point I could not find in no part of the crack front shall be closer to the machine's starter notch by 2.5% of the width of the specimen.
in diagram, he mentioned that width is 0.25 W or 1.3 mm, larger of 2. In the diagram, he mentioned that. You can go through the diagram which is just beside this diagram.
Yes, okay. I will go through that. Only just I have noted whatever the PPT is he has mentioned. Okay, that I will go through.
Suresh, I don't think so. Just going through the PPT is going to help you with the understanding lectures. You have to go through the classes because the PPTs is just a transcript of the classes. It will be more easier, Suresh, for you if you see the class first and try to understand and then go through the PPTs.
Yes, madam, I'm doing that.
So because that is sir will teach even more better in the class actually.
Yes. Okay, madam, I will try to do that a little more seriously. As of now, I am trying
Yes, it's fine.
to listen the class completely once. No, then I was there during that time. Only I was noting down the points which are.
During the node class itself, you try to note down the points and then other assignments also I'll give it to you guys. We can solve especially the MCQs part and then question paper part. We can have a discussion that also so that in that way you guys have a little bit practice on that. But then sir will usually tell along in the class itself, like he'll give the answers and then it will not be there usually in the PPT. Like it is a little bit difficult to get. So you have to make notes while studying only.
Shall we go to next question? 6th is clear, no?
Yes.
Madam, I don't know who are all participating in this. Mr. Kannan. Okay. Coming to 7th. Panel of it 450 mm. Mr. Kannan, can you just you know how to answer this?
To be honest, no, I didn't take that so far. I have some.
Maybe he hasn't completed the class yet, Suresh.
Actually, I could find one formula. I took
This
that formula.
7th question is correct. I got the same answer.
Same answer, no? That W minimum 27 by 25 under root K1C by sigma ys. The same formula I took. With that, I got this value.
Yeah.
But no,
K1C
lot
by
of
sigma y whole square.
correct. That formula that is there in which. Okay, then I feel this is correct.
You can go to next question, Suresh.
Yeah, madam. This question really I find it tough. I don't know why. The electron microscope fractography at a magnification of 2500x, taken at 7.5, 12, and 25 mm from the crack's origin, show regular striations. There are 25, 15, and 5 striations per 25 mm in the 3 fractographs respectively. Initial crack length is 3 mm and the final crack length during the failure is 50 mm. Assume average striation spacing as 0.4 into 10 to the power of minus 3 mm and 2 into 10 to the power of minus 3 mm when the crack grows from 3 mm to 7.5 and from 25 to 50 mm respectively. Madam, in this, no, actually, I could not find much in the lecture part.
Okay, fine. The magnification given here is 2500x. And let me write it down. I will.
Does it mean that, no, what are the 25, 15, and 5 striations per 25 mm? It is told, no? Is the 25 mm means that is as per the 2500x magnification?
Let me see this. So you guys can help me out with this little bit.
Actually, there is nothing related to this question in any of the videos. So I didn't
Okay.
even find any of the answer for this question.
Actually, there is nothing related to this one. Okay, we'll try to solve this then. We'll see.
Yes, yes, yes.
So electron microscope fractography at magnification 2500x. It's okay, fine. So they are taking at 7.5, 12, and 25. This is actual length. So this is not anything taken on. This is the actual length. Total length, I don't know the sample. What is the total length? So I'm considering for whatever it is. Initial crack length was 3 mm. So I'm taking the crack initially. Okay, I'll share the screen. We will see. Like I'll try to write it down on the screen itself.
Should I stop staring my screen?
Yes.
Pardon?
1 second. I'll just take the photo of the question. This is the photo of the question, right? Okay. I'm considering sample has broken like this. And then initially the crack was there about 3 mm. This is the initial length, crack length. And then they have taken 3 around 7.5. 1.5, 12, and 25 consider. From the crack's origin shows regular striation. So crack's origin is this one, right? It will start crack forming from here.
Yes.
So it will be having striations here. And there are 25, 15, and 5 striations. So here there were many striations per
There is one more
25 mm.
50, no? Failure crack length was 50. Is it required to be indicated here?
1 second, let me see. Like even I don't know. Like There are 25, 15, and then 5 striations per 25 mm for per 25 mm, right? So when you take, sorry, when you're taking 25 mm length, you're finding 25 striations and 15 striations and 5 striations with this distance. You are telling Suresh something?
No, the final crack length was 50 mm.
So it doesn't matter, right? Like it has, we are saying beyond 50, right? That doesn't matter, right? The initial crack length is 3 mm, and then final crack length is failure has happened at 50 mm. So it is, so 50 mm, here it is 50. So I don't think so it has anything to do with it. I don't know, like maybe for other questions it is there, but assume average striations spacing is 0.4 into 10 power minus 3 mm. And 2 into 10 power minus 3 mm. Then crack grows from 3 to 7.5 and 25 to 50. Okay, respectively. Assume the striations spacing, assuming striation spacing to be average in the middle zone. What is the actual spacing in mm at 7.5 mm? So it's 25 to 15. So you're finding 20, like, between every 0.4 mm, you are able to find one striations. This is what average means, right? In this distance, in this total distance from 3.5 mm, you're able to, what is this?
3 to 7, 3 to 7.5, ma'am.
It's
3
4
to,
point.
so if we subtract it, 7.5 to 3, it will be 3.5, right? No, 4.5. 4.5. So the average spacing is this one in this region. In this region, it's, yeah. So total distance is this one, and then we are so we'll be able to find out how many striations in this whole region.
25 striations. No?
No, no, no. Yeah, in this region, they have said at 7.5, we are able to find 25 striations.
Yes.
Per 25 mm. Okay. So per 25 mm. So we have to find out the how striations will be more concentrated in this region and becomes less in this as we go away from the crack tip, right?
Yes.
Is it correct? So it will be more closely spaced, and then at the end it will be like having a lot of distance. Is it correct, guys?
Yes, I too.
Or it will be more here and then less here. What it says.
Sorry, ma'am. Sorry, ma'am. I'm lost, ma'am.
Yeah, it's okay. Okay, anyway, that is fine. That doesn't really matter. In the striation spacing to be average in the middle zone. What does the last means? Sentence. Assume the striation spacing to be average in the middle zone. Assume average striation spacing of 0.4 into 10 power minus 3 mm, and then 2 into 10 power minus 3 mm when crack goes from 3 to 7.5, and then 25 to 50. You guys don't know how to solve this one? When I'm a little bit stuck here. Any ideas, guys?
Not for me, ma'am. Maybe we can discuss this next week.
Okay. When do you guys have to submit this one?
Tomorrow.
Tomorrow. Then we'll try to solve it today only. We'll see how if it is
Yes,
possible.
but little give some time for this. Okay. Once you understand this question, the next 4 questions are from the same data. Only, you know.
Okay, you continue doing this. I'll try to solve this. Suresh, you continue with the discussion.
Okay. Madam, anything to do with that magnification value, whatever is mentioned?
Magnification, no. They are giving the values directly here. The initial crack length, it's starting from 3 and then it is going up to 50 when the failure happened. And then they are asking, no. Then 25, no, 5 stations. No, it has nothing to do with 2500.
Mm-hmm.
We don't
Once
have to
again,
do anything.
in this data you see, there are 25, 15, and 5 styrations per 25 mm. It is not for
Yes,
the
per 25
4.5
mm.
or it's per 25 mm.
1 second. So per 25 mm in the microstructure.
Yes.
So 1 second. We have to find out what is the striation spacing at 7.5, 12, and 25 from the cracks origin. Show the regular striation. There are 25, 15, and fractographs respectively. Yeah, here we have to convert it to using 2500x. We have to convert it to how much is actual spacing is. It will, yeah, we will get directly. So we are magnifying it 2500 times means.
Ma'am, but still, mm will be mm only, no? It's only magnification, but units will not change, no, ma'am? That's what my understanding.
No, this from 7 to 12 at 7.5 to 12, if you have if you have to go to 25 mm, right? It means that you will go beyond the 25 mm. I don't think so. This is magnified when you are seeing the microstructure. I'll show you one microstructure. I have anyway here one microstructure. So if I'm seeing one microstructure here, you guys are able to see microstructure?
Yes, ma'am. Yes, ma'am.
So this is at what magnification, I don't know, but here it is 20 micron. So in 20 micron, I'm able to see some scratches. Consider any scratches. Why is it not? Are you guys able to see my mouse cursor?
Yes.
Yeah. Okay, I'm not able to see that. Anyway, so here the 20 micrometer is the whatever scale that I have given down, that corresponds to 20 micron. But then if I see in actual, the total size of the one picture is approximately what, like it will be around 5 centimeter at least. So if I magnify further, so now it is even more higher, right? So the magnification in which sir has given this is 25 mm. So that is at 2500x. So in actual, what is the size of that one? You have to find out the length, and then they are giving 25. First, you have to find out the actual length there, and then they are giving 25 striations in that particular length. And if we divide the actual length to the 25, we'll be able to find the actual striation spacing. So 2500 x means we are magnifying 2500 times. So if it is 1 micron, so you'll be able to see it in 2500 microns. So if you are seeing in 25 mm, so yeah, 25 mm will be corresponding to 2500. Divided by 2500. It will be 0.01 mm. So we have to find the spacing also in in mm only. So in 0.01 mm, we are able to find 25 striations. In 0.01 mm, we are able to find out 25 striations. So 25 mm in 2500 x. So at one magnification, 1x, when we want to see how much will be the so this will correspond to 0.01 mm. So in this 0.01 mm, we are able to find out 25 striations. 25 striations are there. So if 25 striations are there between two spacing means for one striation, how much space does it take if you find out? Is it 40 actual spacing? 40, it will come out to be 4 into 10 power minus 3, 10 power minus 4. So this will correspond to 40 into 10 power minus 3. Means 0. No, 0.4, not 40, sorry. Did anyone get this as 0.4? Suresh, what did you get? Answer? Guys?
Madam, I got 0.4.
Anyone else is got 0.4? Kanan? So similarly, we can do for others as well.
Yeah,
No?
second one, just you please try, madam. Second one, I got some value. I can check. I got around 0.68. Can check.
What is the actual striation spacing in mm at 12 mm? So we know that 25 mm is corresponding to 0.01 mm in actual, because it is magnified, and at 12 we are finding 15 striations, right?
Yes.
15 striations. 0.01 mm. Over one striation, how much distance it will take? (0.67 into 10⁻³ . Is it 0.67?
Yes, madam. I also got 0.67. But I'm not able to convince actually how it has come. Just I have done some permutations and combinations. I got this 0.67. Third one also I will tell you what I got. Third one I got 2. Next question.
What is the actual striation spacing in mm at 7.5 mm? I feel like we are missing out something here actually.
Can I ask a question here, ma'am?
Yes, Kanan.
Now we are talking about bringing in the magnification factor into these calculations, right?
Yes.
But if we consider, the question says that the number of striations per mm is given, correct? That means for mm we can find what is the striations.
They have given per 25 mm, right?
Yeah. I mean, we can find from that we can find the rate of striations, right? So this will not change with respect to the magnification. It's going to remain constant, whatever the magnification is.
Maybe on the scale of 2500 scale, you have to see, Mr. Kannan. Otherwise, there is no point in that. For suppose 5 striations in 25 mm means the distance between 2 striations is around 5 mm. Practically, it will not be that big, that large value, no. Maybe that I feel we have to take that 2500 into this on the magnification scale. We have to take further. We have to divide with that 2500. I feel so.
I have a different opinion because when you have
Kanan, you can tell first, like what you can share your screen if you wanna write it down on.
Madam, this actually I don't know how it has come. That also just you please explain once. After once Kannan finishes.
Yes.
Yeah. So what I want to tell is the number of striations within that particular spacing it's going to be constant. Whatever magnification we see, it is in the specimen. It cannot be changed. So magnification will not play a role here. Is what I feel.
You're trying to say there are 25 striations in 25 mm. So it means that like actual striation will be at 7.5. Then it will be 1 mm, right?
Yeah, something like that. So what I'm trying to tell is the magnification will not play a role in arriving at the number of striations and or the spacing.
Okay. But then I think so we have to consider the fact here the average spacing is there, right? Here 10 power 0.4 into 10 power -3. This it has something to do with it. In that you got the point, Anand, because initially the density of the striations will be higher, and as we move away from the crack tip, the density will reduce. Here they are telling that is fine. From this only we are able to identify the 25, 15, and 5. And then, but then what is the actual spacing in the beginning? We have to find, no? We have to tell, no, Kanan?
Oh, yes,
Madam, in the second, in the question itself, it is given, assume average striation spacing 0.4, it is given, 0.4 into 10 to the power of -3.
So
Definitely, it is not 1 mm or 5 mm. If you don't consider
the
that
actual striation spacing, if the average striation spacing as this one at 7.5, when the crack grows from 3 mm to 7.5, and then in between Akanan, then how we it at 7.5, the average is around 0.4. So when at 7. 5, it will be also 0.4 into 10 power minus 3 only, no, Karan?
Ma'am, I don't know really. To be honest, I do not know, but I'm trying to connect
Understand.
things. And yeah,
Madam, just
Even
I would
if
like
you-
to
I do
know
not know.
something on.
Even if you rule out this point, anyone have anything to say with this? Others?
Yes, yes, yes. Madam, before that, am I audible?
Yes, yes.
Yeah. Now, before that, no, just the 0.67
Huh?
at 12 mm. Just can you please explain how you got the 0.67? Just can you please once?
Okay, okay. Before we start it, I am
Yes.
considering that before. Okay, fine. So I'm considering in this 25 mm is at 2500 magnification.
Correct. Yeah.
2500x. So when at normal without any magnification means 1x as it is, what will be the size? What will be the total length? So it will come out to be 0.01 if we try to find out by cross multiplication. So you have to
Yes.
divide 25 by 2500. So you'll get 0.01 mm. So in 0.01 mm, if I'm finding, I mean, at that point, if I'm finding 15 striations at 12.5, sir has mentioned it at 12.5, 12, it's 15 striations, right? For 25 mm. So for one striation between in order to find out the distance between two striations, I'm trying to find out for 15 striations, or should we find it to 2? That's what I'm confused. Yeah, it is one only, the distance between. So for 15 striations, it is taking 0.01 mm. So for having one striation, how much distance does it take? So if we cross multiply this again, you will get 0.67 into 10 power minus 3.
Madam, your cross multiplication between 15.
For C, sir is telling that there in 25 mm, we are getting 15 striations.
Yes.
In order to find the distance between two striations, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For instance, I'll take 10 only now. So in or consider it is 15 now. It's fine. So in 25 mm, I am able to find 15 striations. Okay. So to find out the distance between these two, I have to divide, so I have to find out the how much space does it take for one striation. That will give me, if see one, consider this x, x, x. So this also
14x.
keeps, yeah. Yeah, we can consider the one which will be there here also, actually one before that. We can start from here, something. So, so if I have to do it 2 then, between 2. No, I think so it is 1 only, not 2. Then what will be the spacing of this one? You have, what is the actual spacing is what is required. 0.67 will be, I mean, if I convert it, you got it now?
And that
No?
0.67 value, just can you just put it there? How 0.67 that multiplication? Yes, can you show me the madam?
Yeah, I used Calci for that.
Okay. Can you just write down like what are all the
Yeah.
values just you are?
So 15x
What are the values you
will
have
be equal
multiplied?
to
Okay.
0.01 equals x is equal to 0.01 divided by 15.
Okay. Okay.
So that will give
0.67.
6.67 into 10 power minus 4.
Yeah, madam, that I have also got 0.67, but I will tell you how it has come. My
Okay.
way of thinking. Actually, the continuation, just to see, if you see the question, assume average striations spacing is 0.4 into 10 to the power of minus 3 mm and 2 into 10 to the power of minus 3. When crack goes from 3 to 7.5, I mean, I have taken at 7.5, I have taken 0.4 into 10 to the power of minus 3. And
Yes.
at 25 to 50. At 50, I have taken 2 into 10 to the power of minus 3. Okay, madam?
Yes.
I have got two values, one at 7.5, one at 50. In between, two more values are there. That is 12 and 25. There are
Yes,
four
yes.
stations here. Okay, two stations I have got. In between, other two stations are 12 and 25. And
12 and
assume that the spacing is average. What I have done, the extreme points are 0.4 and 2. Accordingly, just I have interpolation. If I do, I got it 0.67 and one more value like 1.17. From that, I have got the 0.67. Yeah, you got my point.
No, I lost it when you try to take the average between here, right? Because we have average here at 0.4. We have the average 0.4 here, and at 25 to 15 we have the average of how much? 2 into 10 power 3. So from 25 to this one we have 2 into 10 power minus 3. So you try to find out the average between 12 to 25, right?
Yes.
Because here it is said that assume the striation spacing to be average in the middle zone.
Yes.
So at the average of these two, you will get the average of in the middle zone, right?
Madam, I have 7.5 to 12. Okay, one distance. 12
so the
to
average
25
of that
is.
one. Yes, Surya.
Madam, 7.5 to 12 one, and 12 to 25 second one, 25 to 50. There are three.
Yes, so in the middle you've taken the average, right? That actually makes sense. It is fine in this region. You have to so in order to find in this region, you can take the average. That is fine actually. 2 plus 0.4 divided by 2. So here in this region, the average is 1.2 into 10 power minus 3 mm. The average is this. But then,
you discuss 14, 15 questions.
yes, I mean you guys can discuss. Yeah, Suresh, you can go next.
Okay. Madam, that the 11th question, determine the total number of cycles. Any idea, madam? Just completely I lost the idea actually. How to do this? 11th question.
Do you guys have any idea how to do determine the total number of cycles to failure? From total number of striations, how many total number of striations are there? The total distance is the failure is happening at 50, right? So
Yes.
the 47 will be the total distance. So for every striation, for every cycle, one striation will be forming. In fatigue cycle, I remember I taught you guys in the beginning. So each striation corresponds to each cycle. So we have to find out the average is this one. So in this average, in this region we have the average of 0.4. So total number of cycles will be total number of striations will be 4.5 into 0.4, and then in this region also you have to find out 1.2 into so 4.5.
Madam, it is only number of striations. Why you are multiplying?
Yes,
It's actually 4.5 divided by 0.4 into 10 power minus 3 divided by, not multiplied.
Oh, I'm sorry. Yeah. Yes, it's divided by. Correct. 4.5. Yeah, because each length, right? We'll get total striations plus 7.5, 25 minus 7.5. 7.5 gives 17.5. 17.5 divided by 1.2 into 10 power minus 3 plus 25 divided by 2 into 10 power minus 3.
It is
what?
38333, ma'am.
38?
333.
So many striations.
41,000. Okay. Maybe I will check back my question.
So these many striations will be there, and then these many cycles will be done. Yeah, you guys can discuss now. Suresh, please discuss
Next question.
the
12th question. Just 12th question from the lecture. There, this point it was mentioned. This 0.8 kq. Am I audible?
Suresh, I can hear you.
Yes, Suresh.
Yeah. Actually, in the very first lecture of this week, fatigue pre-cracking restrictions. In that, during any stage of the fatigue crack growth, K1C shall not exceed 0.kq. One point was mentioned. From that, I took this answer. 0.8 kq I have got. Any
Yes,
comment?
that should be, that is correct. Actually, it is mentioned in the video.
Yes.
In the first lecture.
Yes.
I think it should be correct. And 13 also it is mentioned.
Yes.
13 also it is mentioned 0.6 kq and
Correct. In the same, in the maybe immediately there itself it is there.
yes,
Last
yes.
2.5% of crack length should be loaded such that it should be Kmax should be less than 0.6 kq
0.6 kq.
by
Correct.
E.
Correct.
0.3.
Correct.
Okay, this answer is second, no?
Yeah.
Second answer.
Yes.
Coming to 14th. The value of Kmax by E in the final stage of fatigue crack growth. Anybody could do this?
Suresh, you can share the screen.
Yes. Yes, question number 14. I have got 3.2. I have to check actually how I have got 3.
Actually, when I did, I was getting 31.7.
31.6
Like
in 10 to the power of -4.
yeah. Better to
Can you
recheck.
how you have done? Just can you please explain?
Yeah, the same formula by taking P value as P maximum. PQ is P max at the final stage.
Yes.
Yeah. It's 32 kilonewtons I took. I'll just try once again.
I will check that. Actually, my calculate because a lot of arithmetics are there. The arithmetic is there. You must have done some mistake. I will check. Can you tell me the answer actually? How you have taken that the formula? In place of PQ, what you have put? P max 46 kilonewton.
Yeah, 32 kilonewtons. The final stage fatigue growth at P max is 32.
Yes, yes,
So I
yes.
just took 32 kilonewtons.
Okay, okay. I will check that.
Yeah.
What about the next one? Answer can you please tell me? 32. Answer.
I'm getting 31.7.
31.7. Okay, I got 32.
Yeah, I will just verify once. If it is correct, I will reply.
Okay, 15th. P max by PQ for the test to be valid. this I have taken directly from this this point. K1C is equal to 0.8 KQ is given. Anybody is having clue for any clue for this question number 15? It's not 0.8. I think 1.25 it must be. 1.25. Madam?
Is it?
Can you throw some light?
If you don't mind, could you please go a little top? I just want to see that the values for the above problem is there. No? Iterations and number of cycles. If you don't.
I have to go through the lectures for this one, Suresh.
Oh, yeah. Okay, madam. Then we'll maybe. I was finding it difficult to.
I think it should be 1.1. I don't know. In
How?
one of, yeah. Am I audible?
Yes, yes.
Yeah, I think it should be 1.1. In one of the lectures, it is mentioned. I'll just go through if I can. Can you give me just 2 minutes? I'll get back. Meanwhile, we can go further. I will just come back.
Sure, Anirudh.
Actually, this formula was told in the previous week's lecture.
What is the maximum value? The 16th one you guys were able to solve, right? That case in MPa root meter per second.
Then just I have done something. I got 2.75. How I got also just I am not able to collect. Just I have to work out once again.
We have a formula for that, right? KT. And how many total number of time that taken we can MPa root meter is fracture toughness only.
Yeah, for that Tmax by EQ, I have got 1.063.
Achha, in which part of the lecture? Just can you tell me once?
No, this is for 15th question.
No.
Tmax.
Question number is okay. Lecture.
No, actually, I think he has done 85 by 80, which will give 1.06.
Yes, correct.
Yeah, but according to the lecture
and it should be less than 1.1%, right?
Yes, it should be less than 1.1. That's what I have
So
also gone across.
1.1.
So, yeah. Can I share the screen?
Yes.
Yes, Rajesh. Or Anirudh. Anirudh, yes, sir, you can share.
Is my screen visible?
Yeah.
Yes. So here it is. Just so in case of load measure here.
No, actually, it's
And
showing only.
only teams are visible.
Oh, sorry. Just a minute.
You can share the entire screen.
Yeah. Okay. So here it is. Like in case of load measurement, we have seen
The calculation
PQ. Yeah.
PQ by Pmax is that
There again, the recommendation is PQ and Pmax difference should not exceed 10%. This one.
So we can put 1.1 right their answer. Also because there it is showing what will be the maximum load, no? If you go to
Yes,
that question.
correct. That is correct.
Yeah.
Maybe we should use 1.1, but I am also not sure because it is a 2-mark question. That's why I'm afraid.
But here it is written 85 and 80. You should not cross. That is the maximum value 1.1. But if you take
Yeah,
85 by 80, maybe this may be logically looks
1.0 something it will come.
1.06 it will be.
Yeah, which is less than 1.1, right?
Yes, 1.06 I feel maybe looks to be logical from this.
Because the question says what is the maximum value of Pmax by PQ for the test to be valid.
Acha, not for the particular thing.
Yes.
For this particular thing.
So here is the confusion, like whether it is for this particular test or for any test for the matter.
Okay. Yeah, even such a the question is so big. Even understanding the question itself is taking time.
Correct.
Yeah, that's the law actually here. Maybe now I feel 1.1 looks better. Better answer. Okay, shall we go to the next one?
Yes.
This Mr. Aniruddha, could you solve this? The value of K1 by delta T.
No, I have not yet solved anything regarding this assignment.
Anything related to this, you could find something.
No. I have not tried to go through this assignment yet.
I don't know. I got some 2.75, but no, just like that I have some hand calculation I have done and put nothing noted. Where from I have taken, I have to check.
So this
That Ki value you guys find out using the equation we have, right? Fracture toughness. And then divided by time.
Fine.
Is it correct, Anirudh, or other things, or
actually it is given as delta K, right? So delta K is nothing but K max minus K min. Here for K min, if we want to calculate using this formula KQ, it will be 0 only because we have P min as 0, so it will be 0. Am I audible?
Yes. Please continue.
This is my thought. I might be wrong also. If I am wrong, please help me out. So I think this P min is 0. So what we get, K min will be 0 and K max will be whatever is related to this 46 or 32. Based on that, we need to calculate, but I don't know which value to take exactly. or is it this delta P by T what they have given, that one we should use?
Delta P by T, where it is given?
Yeah,
The
delta P
specimen
by
was
T.
tested at a loading rate delta P by T, delta P by delta T.
Delta P again will be 46 kilonewton only, right?
So they have given it as delta P over delta T, which is 105 kilonewton per minute.
They're asking per second, right? Then here.
So we
First.
can convert this into second. Use this delta P only because since we have already seen here, like P min is 0 in any case. We can take this delta P by T value in the place of PQ and find out what is it. This will give us what is the delta Q by delta T, delta K by delta T.
So you're telling we'll find out this value in second and then we'll apply the same thing in the equation.
Yes, then we will get delta K by delta T. I might be wrong also, I'm afraid.
No, nothing. Nobody
No,
knows.
anyone else has anything on this to say? Or do we have to use, we have to apply the equation for load at this one and then find out the K value at this one and this will be 0, K will be 0. Or we have to apply for delta P by delta T.
So if we want to take P max and P min, there are two values. One is 46 kilonewton P max and another one is for the last final stage, which is 32 kilonewton. But here they have not mentioned whether it is the final stage or whether it is the initial stage. They just want us to calculate what is delta Ki divided by delta T.
I think so delta P by delta T is the correct way to take.
Because that is the loading rate. So
yes.
Madam, this question paper also one of the TA must be setting, no?
No,
Maybe
no, this is said by sorry, sir only.
sir will get this much time.
Yeah,
Maybe
might be it would have been from his previous papers from so many years.
No, the questions are entirely different. I mean, similar. The questions are similar. The concept is similar. The question values maybe can be varying. He'll design the paper by himself, actually.
That's what I was telling. Like from the IIT main exam, I mean, what the general undergraduate and postgraduate programs, he would have set many question papers till now.
Yes.
So from that, he would have taken many questions and he would have given us.
Sir has been experienced for what, like more than 20 years, I guess. Yeah.
No, maybe what is my, I mean, he might be teaching I mean.
He was teaching before. He is about to retire now, actually.
Okay. Maybe my age would be his experience.
Possible. Sir is about to retire now, actually. He'll be retiring in a couple of years. He's not taking PhD students
his
also.
Experience might be more than my age.
Ma'am, actually for 14th question, I'm getting now 1.43 something. Can someone cross verify?
14th question.
Suresh, how much did you get?
No, madam, I got 3.2, but I will check. I have to check, madam. I have to do calculation.
Suresh, at least can you tell how it has to be done so that it can be followed? Like,
Madam, it is actually in the formula. The formula is given. We have just simply substituted, that's all. The value of K, okay. Madam, this K, this really I lost the idea. 3 how I got I don't know. Just some rough calculation I have done and put. No, I cannot say anything in this 14th question.
No, maybe it is straightforward only. Instead, in the place of PQ, sorry, in the place of PQ, we have to put P max of 32 kilonewton as one of our just now somebody told we have to use this value 32 kilonewton. Maybe that should be the right one.
3000 cycles, correct, yeah. 32,000 into the test value divided by P.
Yes, BW.
Yeah.
Yes. I think
Now, madam, now I
we have to
recollect.
use that formula and divide it by E. So
By
we
the
will
time
get the. I think the person who gave us the answer could clarify that one.
No, madam, this coming to 13th question, you see that K max, the 13th question. In the option 2, whichever we found it is correct. K max should be less than 0.6 kq and K max by E should be less than 0.32 into 10 to the power of minus 3.
Yes. So then whatever
it is given 0.32 here, I have simply copied.
No, I don't think so. 0.32. We have to write the actual value. The final stage.
That too, it is given as
10
into
power
10 power minus 4. We should be careful there also.
Correct, because it is given 3.3 to 10 to the power of minus 3. Because the answer is in 10 to the power minus 4, I have simply kept 3.2.
No, maybe we need to calculate using that load values. The person who gave the answer just now can clarify on this, please.
That is
Rajesh, I guess.
Pardon?
Rajesh was giving the answer.
Rajesh. No, Rajesh. This girl ME23.
No, she was asking the question.
No, she only calculated and gave.
She only calculated and she told the answer.
She can explain how she has calculated at least.
Yeah, the same way like I took Q as P maximum value at the final stage.
Correct.
And the rest of the values are given in the question. And A by W ratio is getting to be 0.5 there.
Yes.
So I calculated that I'm getting is 1.4 something.
That you will get Q max. Then what about
1.4 into 10 power minus 3.
1.4
1.43 into 10 power minus 4. Yeah, I'm getting the same value. 10 power minus 4 in this case. So obviously it will be less.
1.4
divided with E value, Young's modulus?
E power minus.
Yes, I'm getting 1.43 into 10 power minus 4.
Minus 4 is the.
Yeah, it is obviously less than 0.32 into 10 power minus 3.
Yeah, actually, I used that above formula is there now. Instead of that P max, I just put P max S by.
Yeah, the same way I calculated too. P max is 32 kilonewton.
Modulus value I have just.
Yeah, same thing. Yes.
Emax, why I consider it is that is maximum load at 50,000 cycles. I don't know whether that is the right one or not.
Yeah, here they mentioned that like the final stage of fatigue crack growth was conducted for 50,000 at P max is 32 kilonewtons. So they asked in question also about the final stage. So it should be P max is 32 kilonewton.
I think in this one, a lot of queries are there. Is it possible to share this answer sheet after this this assignment? This one will come, right? The scores are released now.
Yes, I'll see again.
Help us for the main exam.
Yeah, that's what I was telling in the class from beginning. Like, I'll try to discuss, but then whenever I'm doing wrong, I want you guys to correct me because in previous classes and during the assignment solution also, I've used the equations wrong and you guys did not tell me. That's why I thought I'll first study and then next time I'll take the class. So yeah, I'll try to discuss it, but then you guys have to tell me if I'm going wrong anywhere.
Okay, we'll also come prepared.
Yes. We will have a discussion rather, because we'll try to sit and solve the equation. We'll try to solution, then solution will be solving from next class onwards. Because I thought like I'm still not prepared for this. I thought to drop this course, but then I realized at least let there be a platform where you can discuss the doubts you have. That's
Yes,
why I'm
absolutely.
taking the
Last year
class.
also we did not have this plat. Actually, there was no review like this in the for this similar same subject. Other
So
subject.
this question I'll try to solve next time. Next class we'll try to solve this question. Yes. The last question. I'll start with this one and then we will discuss the next assignment in the next class.
If you don't mind, that above answer we want.
This one?
Above,
Electron microscope one?
yeah, that in
Yeah, we were discussing this one as well. Yeah, we were discussing this one as well, like electron microscopy one. And I was thinking that 25 mm was at 22,500 magnification, but Arjun or where Kanan was telling that it is at for 25 mm, these many striations are there. But final the total number of cycles will be like we have to take the average is present, and for distance from for 3.3 to 4.5, the average is uh, yeah, from 3 to 4.5, the average is 0 0.4 into 10 power minus 3 mm. So you have to find out how many striations are there. So 4.5 divided by 0 0.4 into 10 power minus 3 plus in between you have to take the in the middle zone, that is from 7.5 to 50 mm. You have to take the average as 2 into 10 power minus 3 plus 4.4 into 10 power minus 3 divided by 2. You have to do, and then you will be getting around 1.2 or something, 0.4 plus 2
It
divided
is
by 2.
1.2, ma'am. It is 1.2.
1.2 into 10 power minus 3 you will get. So from 75 to 50 means 50 minus 7.5 will be 42.5. In that 42.5 region, you'll be having the average spacing is 1.2 into 10 power minus 3. So you have to divide it by 42.5 divided by 1.2 into 10 power minus 3 plus from 50 to 25 to 50, we are having the average value as 2 into 10 power minus 3. So for 25 mm, we'll be having 2.2 into 10 power minus 3. So you divided by 25 divided by 2 into 10 power minus 3. And the answer we got is approximately 388,333. So this is
Yes.
4.5 into this one, and
Yeah.
10 power minus 3 will be there.
It is around 38,000 cycles.
So this one, other three, the actual striation spacing, I was under the impression that 25 is at 25,000 magnification. So you have to convert it to original actual value, that will be for 1x. So for 22,500x, if it is 25, for 1x, how much it will be, you have to find out. And then if at 5, so it will come out to be 0.01 mm. And then in 0.0 mm, if you have 25 striations, so for one striation, how much will be? So it was coming around 0.4 into 10 power minus 3. But Kanan was telling that is not how it is present. But Kanan, I think this is a 25 magnification only, because it is given here that in 3 fractographies respectively. Fractographies means the SEM images. The images will be looking similar to this one. Kanan, are you there?
Yes, ma'am, I'm here.
I think so, Kanan. This is at 25 mm is at 2500 magnification. I am guessing that, and that's how
No,
you.
this is I'm unable to grasp because
The reason
those
why
stations.
I'm telling is because for 25 mm, 25 striations are very less. And we got the total striation number as 38,333. So these many cycles we have done to have the failure. So if we have at 25 striations for 25 then it will become very less number of striations, Kanan.
Maybe you're right, ma'am. I'm unable to grasp that point.
No, the reason why I'm even telling again is because fractographs are images. After the failure is done, we'll be keeping it in SEM, and then whatever the SEM or stereo microscope or optical anything for that matter, and then we'll be observing the fractographs are called for the images that we got after the fracture is done. So that fractographs we got it at 2500x. So
Okay,
we have to.
fine.
That's and 25 striations are very less for 25 I mean, you got you got the failure in 25 striations only. Even if you consider like up to 50, even it'll be even more less, right? From 7.5. So that's why I'm thinking the 25 in fractography, right? So this 25 is in 2500 magnification.
Okay.
Fine. Rajesh, fine, sir. I don't know. Most of you guys are elder than me, so I don't know who is.
No, it's okay. I'm not sure. Yeah, if we can see that actual answer sheet, then only we can get some idea.
That is also true. We have to see the answer sheet and then we have to find out whether it is correct or not.
Yeah, if they do, then only we can get.
So, but this is the answer for now. We got 0.4 into 10 power minus 5 for at 7.5 and 0.67 into 10 power minus 3 for at 12 and at 25 we have to convert it again and I'll just do it for 25 also.
And if we have completed this session or this sum, the problem, there are new joinees like Arjuna and Anirudh has joined late. So earlier you told us about the exam pattern and all those things. Maybe if you can repeat it, will be good for them.
I have recorded it, Suresh.
Yeah,
Suresh or Kanan?
Kanan, yeah.
Kanan, yeah. I've recorded it, and that's why I thought I'll record half an hour and then I'll upload. That's why I don't expect that we will have a discussion today, actually.
Fine, okay. Let them hear the recordings at the initial stage so that they'll be updated about the exams. Yeah, thank you.
Yes. We will leave then now.
Ma'am, only one question.
Yes, Anirudh.
Last question, ma'am. If we go to that option number 2, insufficient data.
This is not insufficient data. I was telling this one to Suresh also.
Yes.
I mean, we had a discussion and we thought it was not insufficient because fracture toughness will be higher for plane stress conditions. Okay. And then lower for plane strain condition.
Okay.
Yes, Kannan was also saying same thing. Correct.
And
option 2.
I don't know what is the name of the girl who is here today. Like, I mean, she was in ME something. She left.
She
okay.
left. Yes.
She was telling it was saying yes, Anirudh.
My question is regarding examination.
Madam, that curve is actually fracture toughness as a function of specimen thickness.
Yes. So initially, this specimen thickness in the initial case, it will be having plane stress condition, right?
Yes.
And later on, it will be plane strain.
Yes. Actually, there are two curves given. One is steel and other one is for aluminum. Any curve if you take, initial part of the curve is actually x-axis. It is given the thickness of the specimen. Initially, it was high, and afterwards it came down.
And,
yes.
And even in previous video lectures also, we can find this, sir has been constantly telling about this, like the fracture toughness in plane stress will always be higher than the plane strain condition. So he
Yes.
has always been mentioning about it.
Mm.
I think so. It will increase and then decrease. It will become constant.
Yes.
Okay, good. Really, it is tough to maintain that focus for the entire part of the lecture.
Correct.
Any of the things, whatever he says.
Sometimes we will be not in a position to catch the point what sir is making, unless and until we focus again and
Yes.
again. Not a one-time job. Repetitions are required.
Yeah, that is true actually. And then it's not like sir is providing you slides or anything also at the same time. So only transcript is present, that's all.
Correct.
Any prescribed book actually, which is the maybe
I
most of
asked regarding this, sir said like whatever the transcript is given, that is more than enough for this course.
Yes.
Ah.
Maybe for this
not
course,
true,
there
ma'am.
are two good books. One is Engineering Fracture Mechanics by Prashant Kumar, and another book is Fracture Mechanics by T.L. Anderson. These two books are standard books for this subject.
Even I heard of Anderson actually.
T.L.
Prashant.
Anderson is also good, but it is little elaborate. I think if we join to a proper MTech course, then we can read it thoroughly. 3
Anirudh,
months in
you
less
are
time.
from?
No, I am from VTU only. I did my MTech long back in 2012.
That's what I remember. That's what. That's it, Anirudh. Anything else?
I want to ask one thing about the examination. So,
Yes, Anirudh.
in one of the lectures, sir has mentioned that we can take the formulas in one sheet and we can bring it to the
Yes,
examination.
I was discussing regarding this, and 1 second, I'll read out the message that sir said.
actually the lectures were very old ones. Okay.
Yes. So, okay, sir said, data sheet with relevant equations will be provided. They need not carry any written equations.
Okay.
So I don't think so. The data sheet separately will be given. I think so, along with the question only. If the equation is required, relevant, then sir will provide the equation. And you cannot rely on that. And simple equations, you guys have to remember. And the equations like this, probably the difficult ones, like the one which we had at the end, right?
Correct.
Those type of equations sir might give this one, but then like how it is given here, but not the small equations. That those things we have to remember, like fracture toughness, you have to remember all those things.
Paris law.
Yeah, Paris law, yeah, Aries law, whatever law.
In the online exam, no, actually they don't allow even calculators. Like you appear for like GATE or maybe something else like JE and all.
Yes,
You-
calculator will be
you-
given to you
yes, that
on
online
screen.
that calculator will be there. You have to use that. They don't allow a separate calculator.
Scientific calculator.
Okay.
I've told those instructions in the beginning of this class. You guys can listen to this lecture.
Yes, sure.
Chalo, I'll leave guys then.
you.
So next class we'll
Sorry.
try to. I thought of not taking the class actually. I'll just stop the recording. I actually thought of not taking the